In this video, we shall see how to conduct the experiments of analog electronics lab. So, first experiment we are looking at is design and demonstrate a circuit to obtain a fixed DC plus 12 volt from 230 volt 50 Hz AC signal. So, we have the first choice to implement this particular design. The choice one is a half-wave rectifier and a regulator. So this is a circuit diagram. We have a transformer followed by a diode which is acting like a half-wave rectifier. So there is a capacitor used to filter out the AC component. So there is a regulator 7812 which is expected to give a 12 volt DC voltage. Now VA, we are naming the voltage at the input of 7812, which is a 12 volt regulator, VA as the input voltage to the regulator. So from the data sheets it is known that the minimum voltage required at the input of 7812 to have a fixed 12 volt is greater than or equal to 15 volts, and the input resistance of 7812 is approximately 1.5 kilo ohms. So these are the two things, two data we get from the data sheet of 7812. So with these specifications we can start doing the design and estimate the value of C and what are the value of VRMS, which will decide the rating of the transformer. So we know that the waveform at this point A is given by this solid line. So you can see this solid line is just decreasing and it again increases and again decays here. So this what is the voltage at point A. So you can see there is an input voltage which is given by this dotted line, which is written as V in, and there is one more dotted line which represents the possible output voltage in absence of this capacitor C. So now you can see this solid line is over this second dotted line. It goes till the peak and it goes down over here, and we know that this input peak is given by Vp. The voltage at which your capacitor will charge is given by Vp minus Vd on. So we are supposed to design the rating of this transformer. So we know that the minimum voltage that is available at the input of 7812 should be always greater than 15. That is VA minimum. The minimum voltage at this point happens to be Vp minus Vd on, which is this peak, minus the ripple voltage. So ripple voltage is from here to here, we know that. So the peak of this output voltage at VA to the minimum voltage at VA is nothing but the ripple voltage. So we can actually estimate what is VA minimum by knowing what is Vp minus Vd on minus of V ripple. So even the minimum voltage at the input of regulator should be greater than 15 volt. For this to be greater than 15 volt, assuming the V ripple as 200 millivolt and Vd on to be 600 millivolt, Vp should be at least greater than 15.8 volts. If the value of Vp of this secondary of the transformer, if it is 15.8, which will ensure a voltage more than 15 at the input of the regulator, which is very much necessary to have a constant output voltage of 12 volts. So with this specification that Vp should be greater than or equal to 15.8, now we know that VRMS is given by VRMS should be greater than or equal to V peak divided by root 2, which happens to be 11.12 volts. So we are supposed to have a RMS voltage, the transformer rating should be greater than or equal to 11.17 volt. So we can actually find out what is the value of C that is required, because we know that V ripple is given by Vp minus Vd on divided by FRC. This is a half-wave rectifier. So with Vp as 200 millivolt and with the frequency of the input as 50 Hz, and Vp, which is a peak voltage, as 15.8, Vd on as 0.6, assuming the value of internal impedance of the 7812 as 1.5 kilo ohms, the value of C comes out to be 1013 microfarad. So as we can see now in the previous slide, we are supposed to design the value of C. So value of C happens to be 1013 microfarad. So meaning, in order to have a ripple voltage of 200 millivolt with a peak voltage of 15.8 and VDN of 0.6 with R as 1.5, the value of C happens to be 1013 microfarad. Now these are the design values. We are supposed to design the rating of the transformer, which happens to be VRMS, which is 11.17. The capacitor value happens to be 1013 microfarad. So these are non-standard values. So let us choose some standard values close to this design value. So standard transformer rating would be 12 volt, that is 12 volt and 0 volt thing. And capacitor, the nearest possible value is 1000 microfarad. So upon using this 12 volt as the transformer rating and C as 1000 microfarad, the V ripple comes out to be 226 millivolts, so which is close to that specification of 200 millivolt. And A minimum happens to be 16.14, which is certainly greater than 15. So if we choose a transformer of 12 volt and a capacitor of 1000 microfarad, we are sure to get output voltage constant 12 volts, since the input voltage is greater than 15 volt and the ripple voltage is such that the minimum, the voltage at the input of the regulator is always greater than 15 volts, so that we are sure to get a constant 12 volts. So with these selected values, we are bound to get a 12 volt constant voltage. So what are the readings we are supposed to take? So we are supposed to measure what is the peak voltage, the voltage at the peak voltage at the input of the regulator, and what is peak to peak of the output voltage, that is the voltage at the input of the regulator, and the capacitance value that is connected in the circuit, and what is V0. So V0 should be 12. So this will be 12. Suppose if VA minus V ripple happens to be more than 15 volts. So this way we can do this experiment comfortably. So the second choice is, instead of using a half-wave rectifier, we can use a full-wave rectifier. You can see we are replacing it by a full-wave rectifier. Again here also we are using 7812, which requires more than 15 volt. We know that Rin of 7812 is close to 1.5 kilo ohms. So this is what is here we're going to have the waveforms repeating for every half cycle. So you can see now we are getting in the previous case we didn't have the waveform. So this is a major difference as you can make out. So there was no waveform coming here. So this waveform is absent. Now we're going to have a waveform coming in this half also. So now we know that the minimum voltage, this is VA minimum, which is nothing but VP minus VD on minus of V ripple. So assuming V ripple to be 200 and VD on to be 0.6, the VP should be greater than or equal to 15.8, so that we get a constant 12 volts. Now with that VP as 15.8, the VRMS happens to be VP divided by root 2, which happens to be greater than 11.17 volts. So with V ripple given by the equation VP minus VD on divided by 2 FRC. So this 2 is coming because we have the output waveform double the case as in case of half-wave rectifier. Compared to half-wave rectifier, it is double here, that's why it is divided by 2. So the value of C comes out to be 506.5 microfarad, meaning the design values of the transformer is VRMS is 11.17 and capacity is 506 microfarad, whereas the nearest possible values of VRMS and capacitor values are, so VRMS is 12 volt. So even though it is 12 volt, we are supposed to use a transformer which is 12012, which is a center tap transformer. So we are using 12012 transformer, and the capacitance value is 500 microfarad. So by using these values of VRMS and capacitor voltage, we can actually recalculate the ripple voltage and VA minimum. So as ripple voltage is close to 200 millivolt, which is around 226 millivolts, and VA is certainly greater than 15. So we can certainly use this selected values of transformer rating and the capacitor to get the desired output. Again, the readings were as in the previous case. We have to find what is Vp, the Va, that is input of the regulator, what is the ripple at the input of the regulator, capacitor value, and whether the constant output voltage will we are getting it or not. So third choice is using a bridge rectifier and of course a regulator. So we know that this is the bridge rectifier circuit, a capacitor for filtering the AC signal, and this is the regulator. So we are supposed to have more than 15 at the input of the regulator, and Rin is 1.5K, which we assumed in the last case also. Now you can see there is a slight difference here. So this peak is now Vp minus 2 Vd on. So now this is the ripple voltage at the output of this rectifier, that is input to the regulator. So Va minimum should be now Vp minus 2 Vd on minus of V ripple, that is this is your Va maximum, there is a ripple of Vr. So Va minimum should be Vp minus 2 Vd on minus of Vr. So that's what is given here. So we are supposed to have a ripple voltage more than, we should have the peak voltage more than 16.4 volt. Now since the required voltage is 16.4 volt, let us try to find out what is the VRMS of that. So VRMS comes out to be 11.59 volt. Okay, let us try to find out what the value of C to have a ripple voltage of 200 millivolt. So C comes out to be 506.5 microfarad. So these are the design values of the transformer rating and the value of C. So we'll go for the nearest possible value of this, which is 12 volt. Now you can see in the full wave rectifier used actually 12012. Now it is 012 is sufficient. The value of C happens to be close to 506. It is 500 microfarad. So let us verify with these values of transformer rating and the capacitor values. The Va happens to be 15.56, which is certainly more than 15, and we have a ripple voltage around 510 millivolt, which is are close to 200 millivolt was our specifications are. So this is the readings what we are supposed to tabulate. The second experiment is, so design and demonstrate a circuit to obtain a DC voltage with the following specification. The output voltage is 7.7. The ripple voltage is given as 200 millivolt and the load current is 25 milliamperes. So we shall assume a full wave rectifier. So this is a circuit what we are looking at. So since the current is given as 25 milliampere, the DC voltage is 7.7. So the resistance happens to be 308. We can actually find out what is the power rating of the resistor. So power rating happens to be 192 milliwatts. So since the ripple voltage is given as 200 millivolt, with the values of R known and Vp minus Vd unknown, we can actually estimate the value of C here. So Vp minus Vd happens to be the VDC voltage, it happens to be 7.7. We can actually find out what the value of C now. So because we also know the value of R as 308 ohms, so value of C comes out to be 1250 microfarad. So now you can see the value of Vp happens to be 8.3, because Vp minus Vn is 7.7. So therefore Vp happens to be 7.7 plus 0.6, which happens to be 8.3. So to get a 8.3 Vp, the VRM should be 5.86. The design values are, because we want to have a transformer which is center tap, the VRMS should be now 5.86. We can choose 606 transformer. Since the value of R is 308, the nearest possible value is 330. The value of C nearest to this is 1000. So upon using these values, we can actually re-verify the value of ripple voltage and the load. Ripple voltage is coming out to be 238 instead of 200, and load current instead of 25 milliamperes we are getting 23.89, which is fairly okay. The DC voltage we are getting it as 7.88, which is supposed to be 7.7 volts. So this way we can actually comfortably design the. So this is a second design where you can choose bridge rectifier as a circuit, and you can verify the design with these values of R and C we can estimate the values.